come down here and show this.
Sounds good.
Tell me when you're ready. How to give a tired old sailboat bracket a new life and run a more powerful engine and make it work better. That's what we're going to talk about. Let's first look at the tired old bracket. As you can see, it's pretty well made. It's strong, stainless steel, welded. We have it mounted here on a board which represents the transom of the boat. Originally, there were spiral springs wrapped around two places on this. One was here and one was here. Those springs snapped. They, as you can see, were stored or installed between these two arms, this one and that one, which were welded in place. So even if you wanted to replace those springs, you could not do it. As you can see, we just took a tool and cut them off. So let's talk about what a sailboat bracket has to do, because if we're going to upgrade it, we want to upgrade it to do what, so that it does the best job of what its job is. So if you will, please go to the next slide. We'll talk about exactly that. What is the purpose of an engine bracket on a sailboat? Well, the first and most important thing is we want to keep the engine connected to the boat. It's not unheard of for inadequately designed or installed brackets to fall off and take the engine with them, and that is, as you can imagine, a very unfortunate situation. Another problem that the engine bracket also has to solve is that as a sailboat sails, and if you want to use the engine to sort of as an auxiliary to help you go faster or get a better direction, sailboats heel over. So the engine needs to be low down in the water so that the propeller stays in the water.
Sound is really
sorry.
bad.
Echo.
So, yes.
Pause. Stop fan.
I feel more comfortable to redo this part.
Let's
excellent.
do it. Let's do it
excellent.
over. No problem.
Excellent. Excellent.
No problem.
Really well. Much, much better. It's working good.
Good.
What we did so far was very good.
We're going to talk about how to give a tired old sailboat engine bracket an exciting new life. It's going to be exciting because there's going to be something very unexpected happening along the way as we will tell our story. First problem is we want to run a much more powerful engine, which is more than it was originally designed to do, and we want to make certain aspects of it easier to use and more pleasant to use, and for that matter, safer and healthier. So let's go ahead and talk about that. First thing we want to talk about is, let's take a look at our tired old bracket. It used to have springs wound around two places on this bracket. One was here, and the other was down there. Well, they broke. And as you can see, if you look at this, you can't replace those springs even if you could find new springs, which you can't, because they, in the place where they're installed, this shaft is welded to these legs and there's no way to get a spring on there. So replacing the original springs is not a possibility. In fact, as you can see, we just took a tool and cut them off. So now what? Well, let me demonstrate what this bracket does. In this position, the engine is high up in the air. In this position, the engine lowered down, and if you imagine it has a propeller on the bottom, the propeller should be deep in the water, one would think, right? That's what is important to make it work. So to come back up, you raise it up, and it has a little click lock right there that secures it in either the up or the down position. Now, if the engine we're dealing with weighs 90 pounds, this distance here is about 14 inches, give or take. 90, and you are back here in the boat, leaning over with your lower back taking all the work, and your elbows and forearms and so forth banging into the boat, and you're trying to operate this handle right here and raise 90 pounds up and down, that's a big pain in the neck. Very, very awkward and difficult. Now, so what are we going to do? Well, let's go to the next slide and talk about what a bracket is supposed to do. Before we talk about the design proposal for this bracket upgrade, let's first of all talk about what a bracket's job is. First and most importantly, the job of a bracket is to make sure the engine doesn't fall off the boat, with or without the bracket attached to it. So if you remember the bracket we just looked at, it seems to be quite strongly made. That's a good thing. So we can be comfortable. Do we have to start over?
Okay.
Before we start talking about how to upgrade an engine bracket to an exciting new life, let's talk about what an engine bracket has to accomplish to make sure that our design meets those goals. First and foremost, it is the responsibility of an engine bracket to keep the engine from falling off the boat. So the bracket itself shouldn't fall off, and if you remember the previous conversation about this bracket, it's bolted with bolts to the back of the transom. It's not going to fall off as long as you use good bolts and install them safely with non-slipping nuts. Those are often called nylon insert nuts. They don't come undone. The other job of an engine bracket is to be able to be used when sailing to help go in a better direction or to go faster, in case you want to get home, to outrun a storm, or for somebody's not feeling well, any number of different reasons. Then the challenge is when you're sailing a sailboat, it heels over to the side. For this reason, you would want this engine to be down as low as possible in the water. However, when it's in the water very deeply, when you go to start the engine, if you don't have an electric start, then you want the engine to be high up where you can easily pull straight on the cord, and it's easy, natural, and comfortable to do. So these goals are in conflict with each other. So I think we talked a little bit about the problems with the existing bracket. The springs were broken, they were welded in place, and they were too weak. Even if we could replace them, we wouldn't, because the springs were too weak for the job we want to do. But having analyzed this geometry of this bracket, the distance from here to there, of what I'll call the strut length, it's a good length. And we have, as a model for success, another type of bracket. It's very old but beautifully designed. It's very highly regarded. It was made by the OMC Corporation, which no longer exists. You can still find those brackets out on eBay. You need to pay about $150 for one in really fine shape. You can buy a beat-up, raggedy-looking one for about $75. However, rather than go with a whole different bracket, after studying this bracket, it became clear that first, it was strongly made, and second, the strut length is a good strut length, and it's the same as the OMC. So the decision was made to use this bracket. Now, we want some functionality out of this bracket that this bracket wasn't designed to provide, and that's where the excitement comes from. So we're going to reuse this bracket. We're going to upgrade the design and upgrade the materials. Next slide, please. Now, not like anything to do with sailboats or any design problem in general, some of your goals of design are incompatible with other goals, and this is the case here. We want to be able to start this thing easily. We want to have a good pull angle. Well, that means you want the engine bracket mounted quite high. Makes the pull start easy to reach. You pull straight. You're not pulling at a bad angle. So that says you want to mount the engine bracket high up. Another goal, which we'll talk about, this is essentially the heart of the innovation. We don't want to have to lower the bracket all the way down if we're going to be just puttering around in calm water in a marina, picking up an anchor or going to the dock or things of this nature. When you have to deal with lowering the bracket all the way down, and it takes some complicated motions and certain number of non-trivial seconds to achieve it, and you're in a crowded marina, you're running your boat looking in the wrong direction. You're facing backwards when you really want to be facing frontwards. So in a perfect world, you would just reach back, touch this thing, turn around, and steer the boat looking forward. We're going to try to achieve that with our design, exactly that. Another good feature you'd like to have is that it's easy to raise the engine to the storage position. That tells you want to mount the engine bracket high up, where you can pull straight up and it's comfortable to do that pulling. However, as we talked about heeling while sailing, you want the engine low down when you're sailing in rough water. That tells you to mount the engine bracket low. So we have to somehow come up with a solution that deals with all of these different considerations and works successfully. Next slide. So, what are we going to do? Well, we are going to use this device. This is called a gas strut. I'm sure you've seen it. You open the hood of your car or the trunk of your car. It's held up so it doesn't fall on your head or cut off your fingers. It's held up by a device like this. It's a piston. Inside here is a little piston. This is a cylinder. That's a push rod. And this is charged with a pressure. This one happens to be made of stainless steel. I think it's nitrogen inside. And you can buy these things in different lengths. And the amount of pressure of gas stored in the cylinder can come in various amounts. So for example, you can find one that has a pressure of 20 pounds, 30 pounds, 40 pounds, 50 pounds, 60 pounds. Now, for reasons we'll get into in a while, we have chosen 60 pounds, which I think is, for this size cartridge, that's the strongest cartridge you can get. And I'll explain why that was chosen, but I'll show you what happens. If I put this on the floor and push down as hard as I can, it takes a lot of effort to push that down. This is a very strong 60-pound spring. Now, what do we do with it? Well, we're going to get into the details of this later. But notice I've taken the little knobs off the end, and I will make little fittings that will join this threaded end to this position here. This bolt will be replaced by what's called a threaded rod, stainless steel threaded rod, and then this will screw into that fitting that I'm going to make, and it will connect these two places to one another. I'm sorry, I pointed to the wrong thing. It's really, you go across the diagonal of this trapezoid. You go from here to there, and if you see, the length of this gas cartridge is just right for that purpose. Okay? Now, we're going to put one on each side. One of them is going to go here, the other is going to go there. Now, so, how do we know how much pressure to buy? Well, the answer is, we want it to be, let me explain what's going to happen. When these cartridges are installed, they push up with a force of 120 pounds, but the engine weighs 90 pounds. However, this cartridge is not pushing straight up, okay? It's pushing at an angle. And if you remember your vector calculus or your vector diagramming technique from high school, you know that when you work at an angle, you lose the force. So we estimate that 120 pounds of force at an angle of 30 degrees is going to roughly give you 90 pounds of pushing force. Okay? So, what will happen is, with these cartridges installed, you release this, and the weight of the engine is going to pull this bracket down part way. That's the goal. You want it to drop part way. Now, I have a slide. I can show you a diagram of what's going to happen. In the existing situation, if you put this bracket back on the way it was, and you try to start the engine in this position with the engine fully up, pulling on the engine in an up position is very easy, because the pull start of the engine is well above the transom, easy to reach, lots of room, so on. But the problem is the propeller's out of the water, and more importantly, the water pump intake is out of the water. And if you run an engine for more than a few seconds without water going through the water pump, you'll burn out the water pump. Doesn't take very long at all. Just seconds is all it takes. If, however, you lower this down, and if the transom is, say, up about here somewhere, right? Now you're pulling at the engine, you're pulling up to a certain extent. What you really want is you want to go part way. Now you do want to be able to go in this low position. That's important, because when you want to sail in rough water and the sailboat's heeling over, you want that engine down in its lowest position. For calm water and starting, you really want it to be in a position it wasn't designed to do, namely halfway up or so. Okay, it's a tuning issue. We want it to have a position where it's low enough to put the water intake into the water, but high enough to make it easy to pull on the starting cord. Okay? Now, if it's in that position, then you don't have to do anything to it. You can just pop this handle loose and turn around, and it'll drop to the correct level all by itself. You don't have to be back here fussing with it, trying to find that notch or anything. You just knock it out of position, out of its lock, and it sinks down all by itself, and you turn around and you run your boat while looking forward. Okay? So using these gas springs is going to regulate how far down it goes. So what you can see now is the art of design here will be to find the correct strut pressure to achieve these objectives. Now, in order to get the best chance of doing what we want, since we only have to drop the engine below this position about 4 inches to put the water pump and the water intake into the water, we want to have very strong struts that won't let the engine go down very far, because that makes it very easy to start the engine, and it also makes it very easy to pull the engine out of the water, because you've only got to raise it 4 inches instead of the whole travel length. And you can just do that by pulling more or less back instead of leaning over and pulling up on it in order to get the engine to its new position, to its storage position. Okay, now, what are we going to do if our struts are too powerful and the engine doesn't go down far enough? We buy struts with a lower rating. What are we going to do if these struts aren't powerful enough and the engine goes too far down? Well, we would just use a longer threaded rod and mount another pair of struts, say 220s or 240s, whatever it takes, and we would end up with 2 struts on each side instead of, that's a total of 4, and we can add as many struts as we want. Not that we're going to need to do that, and probability is that these are going to work just fine, because 120 degrees of force at an angle of 30 degrees is going to be in the neighborhood of 90 pounds, and that's what the engine weighs. Okay? So that's the only remaining task, is to make little fixtures that have a 3/8 inch hole going this way and a threaded hole to which we screw this. We make those little pieces, 4 of them, mount them, and we're done. That's it. Now, I would like to show the diagram of what success looks like. If you'll give me a moment, I'll bring it up.
I turned it off for a second. It's going really well.
Okay.
The only thing I don't want to step on this, so
yeah.
I'm going to put this in your pocket.
All right. No, where's
And
mine? Oh, okay.
would you
I
like
got
to
it.
sit there over there?
No, I
and
can do
it
this
from
right
there?
here. I just need to pick out the right
And I'd
slot.
like to take you while you're talking, and the background is not set up.
One second. I'm going back where I was.
Okay. I have to fix something else.
All right. There we go.
Give me a second.
Okay. So there you can get the
This light,
screen.
This light is embarrassing for me as a photographer to show my light, so I have to hide it better.
Oh.
I never intended to come this way.
We can do this over. I don't mind.
No, I hate to do it. It's so good. Everything's flowing. I don't. It can't be perfect. It's good enough. We have to start going.
Did you turn it off? I
No,
hope.
I think it got unplugged.
I unplugged it. Yeah. There you go.
Excellent. So I'll do it in such a way that in case you're showing things here, I can still see, but
Okay.
I'm going to have this in
All
the photograph itself. And I want you to be, as long as you are in between the clock and this, your head is in between, that's excellent.
Okay.
Do you want to see this, or how, are we doing
No,
okay?
we want to put that picture
Okay.
up.
Okay, so I'll go back there. Give me a second. Okay.
Okay, so if we are successful, this is a picture of what we have when we're done with this. That is, the pull start is above the transom comfortably. The engine is self-regulating in terms of the height above the water, and when it sinks down just enough so that the water intake for the engine, which keeps it cool and keeps the water pump from burning up, is in the water. So that is what success will be like if we can get there. And again, we probably will be very close by choosing two 60-pound struts, but we have all the degrees of freedom we want or need by either adding more, I don't think we could get stronger ones, but we can add additional ones without any difficulty. It just means making more little connectors and making longer threaded rods, that's all. And we can tune this to be exactly where we want it.
Yep.
That's it.
Okay. Do you want to say a couple of final words?
Now, if you don't want to make the little fittings that I talked about, you can buy little fittings from the same companies that sell struts. And by the way, let me read you the name of this product. This will require glasses. Give me 1 second. Here they are. Very nice. Thank you. Whoops. I got it. All right. I think I bought these Nitro Prop Strut and Spring. This particular product is NP-SS-1500-60. All right. www.strutyourstuff strut-your-stuff-here.com. strutyourstuffhere.com. There you go. They also sell these little fittings that have a ball, and you can use these nylon clips that are already on here if you find a way to attach those little fixtures to whatever your bracket may be. You don't necessarily have to make the little fittings that I'm talking about. For me, however, because I have the ability to do it very simply, I'm going to use aluminum, and I'm going to just this, by the way, the threaded ends of these struts are 1 by 6 millimeter. Okay, if you go to the hardware store and try to buy nuts or bolts, it's metric, and it's a 6 by 1 thread. So I just bought a drill and a tap to match that thread from the hardware store, And I'll just use a little bit of aluminum, drill a 3/8 inch hole going horizontally, and one of these 6mm holes going vertically. Make 4 of those things. Replace the bolts that are in the bracket with threaded rods, put them on, put nuts on them, there you go, we're done. Then we test it, and we increase or decrease the force as we find it necessary. So I think these changes should transform the experience of my friend's use of this bracket. Although he doesn't complain about it and doesn't seem to suffer too much, but why should he suffer at all? I mean, come on. Let's make it as good as it can be. That's it. Bye.